Today we are going to do the introduction to classification task. So already we've looked at regression, and from our previous class, as we discussed, regression is for models that deal with continuous numbers. For example, if you're trying to predict the tip amount, then we will work with continuous numbers to fit a regression model. Today we will look at something new, and that is classification and how do we fit classification models. Yeah, so classification is a type of machine learning task that involves predicting a categorical label for a given input of data. So from your introductory to statistics class, so Abraham showed you the different kind of data you have, and here we have categorical data. So categorical data is a data set where we can differentiate between two things. So for example, male or female. So things like that. So in other words, the goal of classification is to assign a label from a predefined set of labels to each input data point. So we can have an example. So if we took an image in a park, and we wanted to train a classification models. So we could train a classification model that takes in features such as the shape, size, color, and height of an animal. And then from that image from the park and these features that we have, we could verify if what we are seeing in that image is a dog, cat, bird, etc. So any of those, so any animal that might be in the park. So classification is one of the most common types of machine learning tasks, and it has a wide range of applications in various fields. And some of the fields include spam filtering. So if you check your Gmail account, we have spam and non-spam emails. You can also use classification models for credit fraud detection. Okay, so there are several method models we can use for classification, and some include logistic regression, decision trees, KNN, and support vector machines. So we will discuss each and every model in detail. Okay, and when evaluating a classification model, we can use the score part, but here we will prefer to use the F1 score. But I'll show you that also in our class. So let's have a look at one of the models that we use here, and that is the logistic regression. So for the logistic regression, the equation that we have here is, is this. So we have the probability of x being equal to 1 divided by 1 plus e power negative wx. So what does the w represent, and what does the x represent, and what does the e represent? So here the w is the weight vector and x is the input data. Then e here is the exponential. Okay, so you all know what exponential means. So this is the equation for logistic regression. So unlike linear regression where we had y is equals to mx plus c. So when dealing with logistic regression, what we are dealing with is this sigmoid curve. So this is the sigmoid curve. So if you check this from, let me open this image in a new tab, and then you'll get to see it. So we are dealing with this curve here, so that any value that is here on the left hand side from where we have 0 can be classified under one class, and any value that is above 0 and it's positive can be classified onto the other class. And that's the work of this equation that we have here, and that's the reason as to why we have classification. So for example, we can say on the left hand side should be males, on the right hand side should be females. So let's go into the practical part. So the practical part is not included here, but let's create a notebook for that. So what I'll do here is I'll create a new notebook, and this will be for logistic regression, and classification. So that's my new notebook. So logistic regression, classification. So these will be the introductory to classification models. Then what I want you to do is I want us to use the tips dataset again. So I'll import the same libraries we imported from our last class and also import the tips dataset again. But here our approach will be different because we want to see which column we will use for fitting a classification model. So I'll give you 4 minutes to copy this, then we can proceed at 8:15. So set up your Jupyter notebooks, import the libraries, and yeah, import your data sets too. Then we can proceed on from there. Okay, so we can proceed. So let's check our data set here. So anyone with a question? Oh, okay, let's continue. So here you can see we have total bill column, we have tip column, sex, smoker, day, and time and size column. So what I'll want us to do is maybe pick the smoker column and use it as our target variable. So here our y should be equal to the smoker column. Okay. So what we will do is we will create a subset of the data So here we will have tips subset being equal to tips, total bill, tip, and smoker. So I'll include the size also. And that will be the subset of our data. So if we check the tips subset dot head, that's what we have. Let me share this in the chat section. You'll copy the code as we move on. Then the next thing we are going to do is, because you see here, one thing you need to note is when fitting machine learning models, so you need to eliminate all categorical columns. So if we check tips subset dot info, you can see this is a float, this is a float, this is an integer, but this is a categorical column. So what we need to do is we need to convert this categorical column to be numeric first. So what I'll do is I'll make this a copy instead of having it being a dataset. Then here I'll create a variable called smoker map, and the smoker map will be equal to that. So if yes, then a smoker is 1. If no, then a smoker should be 0. So it means you are a non-smoker. So when we see a 0, it means you are a non-smoker. When we see a 1, we know that you are a smoker. Then here we are going to select that smoker column and say that the smoker column should be equal to tips subset, then smoker.map the smoker map. Yeah, and if we go ahead and check the tips subset.head, you can see now the smoker column is numeric. And if we check the .info part, then the smoker column is it's still a categorical. So let me check the .head part again. Yeah, so it's a 0, 0, but categorical. So what we had to do is, so if we maybe select the first value, so I say smoker. So just a minute, and you will copy the code that I have here. Then I select the first value and I check the type. You'll get to see that this is a numpy integer. So even though it's categorical, so from the .info part, even though the smoker column is categorical, we know that we've converted the values that are in there to be numeric instead of us having strings. Okay. Yeah, so that's what we have. So I'll copy this code and paste it in the chat section. And you can go ahead and copy it and paste it to your code editor. So I'll give you 5 minutes to do that. I guess 3 minutes should be enough because I've shared the code in the chat section. Then we can proceed on and feed our classification model. So this should take you back to the basics of Python class. So I guess this was taught when you are dealing with functions. So how to do the mappings. So this is one of the applications of the map function. So you learned something on the lambda function, and also we had the map, the apply functions. So those were the three functions you learned. So the lambda function can be, we can use the lambda function in our work. We can also use the map function. So this is how you apply the map function when it comes to data frames. Then the apply comes in when you're dealing with lambda plus this. Okay. So at 8:23, we proceed and we feed our model. So I'll save the file and I'll wait for you to finish copying the code. Okay, so let's proceed. So now that we've created our data subset, let's create our target variable and features. Okay. So here we will have our X being equal to those three columns. So I like using this method. So dot drop smokers. Then our Y should be equals to the smoker column. Yeah. Then the next thing we do is we import our logistic regression model. So we will have from sklearn.linear model import logistic regression. Then we instantiate the model. So we will have logreg, short form for logistic regression, being equal to logistic regression. Then we feed the model. So logreg.feed. Then it's not a must we make predictions, but we can make predictions. Logreg, we can have our ypred being equals to that. Then lastly, score the model. So we will have logreg.score xy. And if we run that, let's see what kind of accuracy we get. So we get a model that is 65% accurate. So here we can have print model accuracy, and then we can have that. So the model is 65.98% accurate. So not the best accurate you could get, but this is based on the data that we are using. So for the next tasks that we will be doing, so I'll get data that is specific to the given task because this is the introductory part. So I'm just showing you how we fit models, how we get the score, how we get the predictions. So in the next class, I'll have to open platforms like this one. So Zindi platform, where you can see we have such kind of a task. So can you predict when a network fault will occur? So you can see this is a real world problem. And maybe if you are interested in participating in such kind of projects, you can see the price for this project is 1,000 USD. So you can actually be paid for coming up with solutions for these kind of tasks. And here you can see we have some data sets that we can use. We have the trained data. So trained data is most likely used for training the model, and test data is used for scoring the model. So let me share this code in the chat section, and you can copy it from there, and then we can discuss the results that we get here. So again, I'll give you 5 minutes to do this. So we've been doing this. So you see this is repetitive. So creating the target and the features, importing the model, instantiating the model, fitting the model, making predictions. So this is something we've been doing repetitively. So at 8:30, we will wind up the class and discuss what we've done for today. And maybe a task I'll give you is to maybe predict. So for the first, okay, so what should you do? So for the first 5 rows, predict and append the predicted. So that's what you should do. It's actually easy. So here you can see. So for example, here we had the smoker column being 0, the predicted value being 0. We have some minor instances where we have the prediction being incorrect. So for example, this one, and these are the ones that contribute to the us having these lower accuracy here. Yeah, so finish copying this code, then you'll work on these on later on after we are done with the class. Okay, so I guess you might be done. So let's explain what we've done here for today. So first of all, we have this tips dataset. And from the tips dataset, if you check, we have total bill, tip, sex, smoker, day, time, and size. So using the total bill, tip, and the size that these columns that we have here, we can go ahead and predict if someone who came to the restaurant was a smoker or a non-smoker. But thing is, we won't be 100% accurate. So as you've seen, our model is 67% accurate. Then what we went ahead and did is we created a copy of this dataset with only the columns of interest we had. And one of those columns was total bill, tip, size, and smoker column. So which are numeric. So a question you will ask is, why are we excluding these categorical columns? So yes, we are excluding the categorical columns because if we were to fit a model that will include all these columns, we would have to convert these categorical columns to be numeric. And one of the ways we could do that is we could use the pandas get dummies method. So you were taught that already. And the get dummies method converts these values that we have here from being categorical to numeric, but it will create some few extra columns here. So we will do that practically and you'll get to see what happens. Okay, so this is one of the ways of encoding categorical columns. So we could do the same for all the other columns, but I decided to just work with the smoker column for now. But I'll show you, we will have another session where we discuss these alone. So we created our data copy and we've pre-processed our target column, which is the smoker column. So after doing that, what we do next is we create our features. So we will have three features. So feature number one is total bill, feature number two is tip, feature number three is size. And then our target column was the smoker column. After doing that, we import our model, which is logistic regression. We instantiate the model, feed the model. So predictions are not that much important for us today, but tomorrow, yeah, we will use them for something else because the kind of score we are using in this session is just the accuracy score. So which proportion of the correct values have been correctly predicted. So that's what we are using. But for us to get a better overview of how our model is doing, then we need to use the widespread values, and that's why we have this part here. So yeah, so if we check the model accuracy part, you can see we get an accuracy of 65.98. And if you want to see the predictions versus the actual, you can go ahead and create a new column, add the predicted values, and you can compare the values that you get. And that should bring us to the end of the introductory class to classification models. Any questions on what we've discussed?